Hello everyone. In this video I'm going to work through an example of a circuit that includes opens or shorts, and I'll show you some ideas of how you can think about so you can successfully work on your own circuits. So let's look at our schematic. This is a fairly simple schematic. It includes an independent voltage source whose value is 10 volts, and it includes 4 different devices that I have called them here A, B, C, and D. The main question that we want to answer is how much power each one of these devices is absorbing in this particular scenario. What you probably are focusing on right now as you're looking at the circuit is the existence of 2 opens. So there's an open here and there is an open here. And those are key features of that circuit because they actually prevent current flowing. So for example, if I look at this open here, the current through this open at this point will of course be equal to 0. And since there is really no current that flows through this open, it clearly means there cannot be any current that's flowing through device D. It would basically be abruptly stopping there at this open, and that is something that is not allowed. So that means that the current that flows through this device D should be equal to 0. So since the current through this device D is equal to 0, honestly the voltage drop across device D does not matter. The power that would have been consumed by device D would have been the voltage drop across device D in the passive sign convention times the current through device D, and of course this is equal to 0. So device D consumes no power. For very similar reasons, there is really no current that flows through this open circuit, so this current here should be equal to 0. Really, that means that the current through device C will be equal to 0, and that means that the power that device C is consuming is indeed equal to 0 watts. It's actually interesting that if you now go a step back, device B will behave in exactly the same way. If you do assume that there was some current IB flowing here, you would very quickly come to the conclusion that this IB is equal to 0. Why? Because as this IB is flowing through this device, it will have a choice to go down, but we know that this is 0. Or it might have a choice to go to the right, which again, we know that this is 0. So there is really no path that would result in a non-zero current. We only have 2 possible paths here, and that current will be 0 in both cases. So that means that IB will be equal to 0, and that means that the power consumed by device B is also equal to 0 watts. So these 2 breaks, these 2 open circuits we have in that circuit, essentially have yielded devices B, C, and D inoperable. So they're consuming 0 watts. The only power that can consume some amount of current here is actually device A. And as you will see, as this current of half an amp is coming from the left, it now has a choice. It can either go to the right, that is actually going to be 0 amps, as we just learned, or it can go down. And that means the current now that flows through this device A will be exactly equal to 0.5 amps. So now we do know that there is a current through device A, half an amp. We do know the voltage drop across device A. Look, this node, which of course is the same as this node. And then we have this node, which is of course the same as this node. So the difference between the red and the green nodes is exactly 10 volts as imposed by the voltage source. And that means that the power consumed now by device A will be equal to the voltage drop across it, which is 10, times the current through it, which is 0.5. In the passive sign convention, indeed, my half an amp is flowing through device A from the plus node. So I do have passive sign convention, and therefore I have 5 watts consumed by device A. So this is the end of the example. I do invite you to look back at all the steps that I discussed. You can watch the video again and really convince yourselves that the currents through devices D first, C second, and B third are exactly equal to 0. And finally, device A is consuming half an amp. So thank you very much. We will see you in the next video.